Welcome. This is Mr. Fisher Flips 3rd grade math. We're using math expressions and we're going to be looking at lesson 4-3. And our objective today is to use place value in word problems. We're going to be looking at understanding and solving these exciting word problems. And the best way to do that is to understand the place value. And we've been doing place value drawings to help us understand how to group and ungroup these multi-digit numbers, to add them and subtract them and put them into a word problem. It's going to get exciting today as we look at those objectives. Let's get started with anytime problem. And let's look at this problem. This is Cole created a 3-digit number. The hundreds digit is 5 greater than the ones digit. I've placed 3 boxes here, or 3 lines, so that we can fill in the 3 digits. So the hundreds digit is 5 greater than the blue one, and we're going to put just a B there. 5 more than B, the blue, the ones column. The product of the tens and ones digit is 8. So green times blue equals 8. So we know green times blue equals 8. The sum of the hundreds and the ones digit is 9. So we know that this plus this equals 9. And a better way to write that would be red plus blue. Okay, and that equals 9. So we've got to figure out the best way to do this. If we know that the hundreds digit is 5 plus b, let's get some numbers here. What plus b equals 9? And it has to be 5 greater than the blue one. So we could go with 9 plus 1. Nope, that doesn't work. 9 plus 0, there we go. Okay, 9 plus 0, could that work? Let's put 0 back in here. 5 plus 0, and green times 0 equals 8. That doesn't work. Let's go try 8. 8 plus 1. Let's see if that works. If we put the 1 in, 5 plus 1 is 6. And green times blue equals, if we made that a 1, that doesn't work. Well, because if that was 8, that would have to be 8. Let's try another one. How about 7 plus 2? Let's put the 2 as a blue and 7 being the red. Okay, so if we go 2 plus 5, what's 2 plus 5? That equals 7. Hey, I'm liking that. There's a 7 there. Now let's go back through, put a 2 here. 2 times green equals 8. So if we put this as a 2, 2 times what equals 8? 2 times 4. So let's check to see how we did. And it is 742. Awesome, we got it. And look how we did it. We did it correctly. 7 minus 2 equals 5, and 7 plus 2 equals 9. And the tens digit is 8 equals 4 times 2. So it took us a bit, but we were able to do it. Well, make sure you're practicing your 6s, 7s, and 8s. Just the other day, I had to make sure that I remembered 8 times 7. And 8 times 7, if you don't practice it, you lose it. Right? 8 times 7 is 56. That's probably the hardest one on the multiplication table that I have to remember. Well, let's get started with some practice here. And to practice today, let's look at a model. And I've set this up already, and we've got some thousands here, some hundreds, some tens, and some ones. And so let's look at this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 100s is, everybody, drum roll, 1,000. And 2 tens is, not 2 tens, 200s. 200s. 200s is 200. So we can slide that over there, and now we have 1,200. Okay, now we have 3 sticks. How much is 3 sticks? 30. And 1, 2, 3, 4, 5. How many is that? 7. So our total number is 1,237. Let's look at another number, 1,263. So we need to change this. Let's get rid of that. 1,263. Let's get rid of the 7. But can we keep the 1 and the 2? So let's go to the tens and let's pull up a 60. And let's pull up 3 ones. Hey, pretty good. Now, can you do that with a place value drawing? Sure you can. 3 dots equals 3. How many sticks am I going to use? 6. Excellent. How many boxes of 200 boxes? That's right, 2, because the boxes equal 200. And we already figured out this, and instead of doing boxes, we can do that's right, we can do an up and down. Well, let's look at the different ways that we can write that. Here's 1,263. We did it as a place value drawing and using our secret code cards. But we can also write it as 1,263. Oh, sorry. 1,000 plus 200 plus 60 plus 3. We can also write that in word form. In word format, it looks like this. 1,000 plus 2 hundreds plus 6 tens plus 3 ones. And what's another way to write that? Can't we read that also as 12 hundreds plus 6 tens plus 3 ones? Can you think of another way we can do that? What if we did, instead of 12 hundreds, what if we did 126 tens plus 3 ones? Is that the same number? Think about it for a second. It is the same number. 126 tens plus 3 ones is the same as 1,263. Be aware of that. Well, I've got this number 212 and I want to line it up and watch it line up. That's cool. And it puts the 200s together, the 10s and the 2. Well, that's pretty easy. Let's add some numbers to it. Okay, what if we had instead, let's erase that. What if we had 1, 2, 2008. 2008, do we have any 100s? Do we have any 10s? Do we have any 1s? Let's try it. 110. 2010. Uh-oh. We want 2008. 1, 2, 3, 4, 5, 6, 7, 8. Line them up. And 2008, notice there are no 100s and there are no 10s in that number. Well, let's start looking at some of these problems. What if Scott baked a batch of rolls? He gave a bag of 10 rolls to each of 7 friends. He kept 1 roll for himself. How many rolls did he bake in all? Well, we can use our iTools today to figure this out. 10 rolls for each of 7 friends. 10. Wait, there's a 10. How many friends did he have? 7. Let's put on 7. And they lived all over the city. And he kept 1 roll for himself. Let's give him a roll. So Scott had how many rolls did he bake in all? Well, before we line it up, let's check with a place value drawing. We had 7 bags of 10 rolls. So we have 1, 2, 3, 4, 5, 6, 7 sticks and 1 roll. Let's line it up, and we have 7 sticks plus 1 So Scott baked how many rolls? 71 rolls. That gives you a visual of how to do the place value drawing, and it goes right along with using the cubes. This one should be easy. Pause the video though and see if you can do this on your own. Okay, starting back up. Let's see if we can do this. 8,000, right? 8,000. And then what? That's right, we need to put a plus there. How many hundreds? 300. Plus how many tens? 0 tens. Can we do that? Technically, yes, you can. But there are no zero, or there are 0 tens. How many ones? 5. Okay, let's check your answer. Sample answer is 8,000 plus 300 plus 5. Notice ours is a little bit different, but we got the same answer. It equals 8,305. Pause the video and see if you can do this one. Okay, we have to use a place value drawing to help us answer this problem. Or we can use a place value drawing. Well, let's look at this. 743. Well, let's do the 3. 1, 2, and 3 circles. That represents this. How many sticks do we need? 1, 2, 3, 4. That takes care of the tens. And how many hundreds do we have? Good. We need 7 boxes. Now they put the cans in boxes of 10. How many boxes did they fill? And how many cans were left over? Here's our answer. 74 boxes. There's 7 plus 4 more. 1, 2, 3, 4. 74 boxes plus 3 cans are left over. To make sure you understand that, let's make sure you understand how to put this number. That number is 1,659. What digit is in the tens place? A 5, right? What's the value of that 5? 50. What digit is in the thousands place? That's not the thousands place. There we go. A 1. What's the value of that 1? No, it's not 1. It's 1,000. The value is 1,000 because it's in the thousands digit. Okay, what's the value of this 6? That 6 is in the hundreds digit and it represents 600. Okay, hopefully this is getting easier for you to understand. Well, what is place value? We have this number 1,729. Place value is the value of a digit's location in the number. So 7 is in the 700s place. And the 2 represents 20 because it's in the 20 spot, in the 20s value spot. So the place value gives each digit its value. There's a 9. It's in the ones column, so it's only represent 1. 9. That's what place value is, the value of a digit's location in the number. Well, let's practice. Let's practice the number 2,783. I'm going to start with the ones column. 3, 1, 2, and 3. And I said 80, so I need 8 sticks. And I said 700, so I need 7 of these. 1. Almost didn't have enough room. And 2,000. 1,000, 2,000. So if we cover up those ones on the bottom, we have in the top 1,000, 2,000, 100, 200, 300, 400, 500, 600, 700, 2,783. So that's using the digits. Remember to use that. Well, I was told I did not put the link on the website, Virtual Manipulatives Library, so I put that on there and it's under Virtual Manipulatives. Well, I also was told that I'm not giving enough challenges. So here's a challenge. If you want to stop the video, you can check this out. You get a timeline and you try to see if you can figure out 3 things that have happened since the year 1500 and today. Well, some other challenges that I'd like you to try, if you'd like. Stop the video and see if you can try these 2 mystery numbers. Since they are challenges, I'll let you figure it out on your own and we'll see if you get them right. Also on the website, I've put a PDF under this part of the lesson, and I've made sure these links are hot. So in the PDF, you should be able to click on these links so you can check out Shark Number V2. You can also check out these two that I talked about earlier on the previous assignment, and you can check out the place value calculator and place value cards. Another thing that you can check out is this YouTube video, and this is actually about 7 minutes long, and they have to count these eggs in so many minutes, and they counted happily ever after. It shows you how to do place value as you count, counting in tens and 100s, and they show a fast way to do it. Here we go. Make sure you do a WSQ tonight. When and where did you watch the video? Sum up what you saw. What was the main idea of tonight's lesson? Problems. Yep, word problems. And question, write one question you might have been able to collect from watching the video. Remember, if you don't have a question, think of something that you can ask someone else, or create a word problem. Excellent with especially tonight's lesson. So that brings us to the last of tonight. Remember, and that's all I have for tonight.